Bigger is not always better. SXE versus SXR, the long-awaited video. Let's delve into what Borg-Warner have done by reducing the diameter of the rotating assembly, increasing mass flow rate, and obviously horsepower. Today, you're going to learn something. Borg-Warner are brilliant. They have got smaller rotating assemblies, I'm talking about the compressor stage now, with higher mass flow rates, and we're going to go into the compressor maps, overlay them, and see where the differences are. But one of the key differences that you'll notice will be Borg have gone from 7 blade to 6 blades. It's uncommon for turbo manufacturers to go from a multi-blade design to a lesser count blade when increasing mass flow rate. Borg have done just that. That's really weird, but they've also decreased the size of the compressor wheel. Okay, the first turbo we're looking at here is the larger of the S300SXE, and that is your S300-5091. It's an 1100 horsepower capable turbo, and the compressor wheel measures 91 by 72 on the inducer. So 91 millimeter exducer, 72 millimeter on the inducer. Turbine shaft is 79.76, otherwise referred to as the 80 mil shaft, and the exducer is 73.37, call it 73.5. Turbine blade is a 10 blade design with a cutback. All the SXE and SXR turbochargers are oil cooled only, there's no water jackets, and you have a hose in and a hose out. There's your inlet, there's your outlet, speed sensor port, which is not drilled all the way through. It is pre-drilled, but you still need to drill the last millimeter through the housing. And you have a boost only source, once again pre-drilled, but not all the way through. You'll have to just continue that little hole all the way through into the compressor housing and deburr. You'd need to remove the compressor housing to do that. Different options you have for turbine housings will be what you see in front of you. T4 inlet with a V-band out, AR 88.88. You get that for the 80 mil turbine wheel as well as the 76 mil. The next size up will be a AR 0.91, which is a twin scroll T4 inlet with V-band out, and you get an AR 1.0, also T4 twin scroll and V-band out. On the left hand side, S300SXE 7 blade splitter, and on the right hand side, the replacement S300SXR 6 blade splitter, and the obvious black anodized compressor wheel. The size difference in the compressor is a noticeable 91 exducer, 72 millimeter inducer goes down to an 88 exducer and a 68 inducer. So we're 4 mil smaller on the inducer and 3 millimeters smaller on the exducer with the same flow rate, but there's a 2% increase in efficiency. The SXE was 74% efficiency, max efficiency, and the SXR is a 76% efficiency. Okay guys, so this is the compressor map for the S300SXE, the -5091, 1100 horsepower capable turbo, and it's running the 91 millimeter exducer compressor with a 72 mil inducer and maximum efficiency of 74%. And just to set the baseline and just give the guys that haven't seen any of my reviews before a bit of an idea of what we're looking at, this figure over there is atmospheric pressure at the coast. That's the outside ambient air pressure that you would be breathing in if you were at the coast, 1 bar, and that is essentially 0 bar gauge pressure. So your P to C, or your pressure ratio, from atmospheric to 1.4 would basically be a difference of 0.4, and that would be your gauge pressure. The maximum efficiency island starts at around 47 pounds per minute, and it goes up to around 65. So 470 horsepower, 650 horsepower, and you'd start finding that maximum power is 110 pounds per minute of airflow, which is essentially over there. You actually get a little bit more So you'll probably find that you'd make 1120, 1115, right about there horsepower. Nice thing about this turbo, low boost gets you where you start seeing the maximum efficiency island, 0.8 bar gauge pressure. And we'll go up to approximately 2.5 bar pressure ratio or 1.5 bar gauge pressure. Maximum power is made around about 2.3 bar, and you'll be able to make that continuous high horsepower number at max flow rate up until approximately 3.2, maybe 3.3 bar before the power starts falling away. Right guys, this is the S300SXR compressor map, and to start off with, here is your 1 bar atmospheric pressure outside, 0 gauge pressure, and maximum horsepower or maximum flow is just above 100 pounds, maybe 102 pounds, and maximum efficiency, it's really small, but that's 76%, and it is generated from a 68mm inducer and 88mm exducer compressor. So let's have a look at the flow rates on your maximum efficiency island, which is approximately 63 pounds per minute of airflow, and starting at around about 43, 44 pounds. At the same time, the boost pressure, or P2C, that is required is approximately 1.75, 1.77 P2C, and it ranges up to approximately 2.6 P2C. And nice thing about this, it's actually a compressor that will get you to your maximum horsepower at around about 2.1, 2.15 of a bar, and it will stay at its maximum flow up to approximately 3.25 of a bar, and then it starts to fall away. When it does fall away, you know, when you start getting up to boost pressures like 3.5, 3.6, 3.65, you're still producing 95 pounds per minute. It's 950 horsepower. So you start seeing what this compressor can do. Now, the increased efficiency is one thing, but have a look at this. At half a bar gauge pressure, you can already produce 630, 640 horsepower. At 1 bar gauge pressure, you can produce over 800 horsepower. 1.5 bar, you're sitting at 920 horsepower, and a touch under 2 bar, you're sitting at 970 horsepower. So most street cars that run pump fuel with octane boost will be able to use this turbo and generate close, very, very close to 1,000 horsepower. You'll be able to max this turbo out horsepower-wise, provided the engine can use the airflow at a 2 bar, maybe 2.2 bar, which isn't putting excessive loads on any engine internal. So it's actually a fantastically sized and a beautiful design turbo, especially for 4-cylinder engines that are high revving and can put to good use this sort of mass airflow.
This shaft here is a turbine wheel without a cutback. You'll notice that the exducer blades are horizontal with a horizon. We're talking about these 2 blades over here. They are level with the horizon. And this blade here is a cutback on the turbine blade. Here's a closer look. If you have a look at those exducer blades, you'll see that they angle downwards, and that is what we call a cutback. The larger S300SXR as well as the S300SXE both share the same turbine blade, 10 blades. They share the same cutback, the same aerodynamic design. Where you find the difference for the SXR versus SXE is in the aerodynamic design of the compressor wheel. Let's move on to the smaller range of the S300 models. This specific turbocharger range uses the 76mm turbine, and the S300SXE used to produce 825 horsepower with a specific part number, and its replacement with a smaller rotating assembly now produces 950 horsepower. Exactly the same 76mm 10-blade turbine wheel without a cutback. Let's get into the sizes and let's talk a little bit more about the turbochargers themselves. As you can see, both turbochargers use the same turbine wheel, and both of them measure 76 millimeters. Now, what's really interesting with these two turbochargers is that there's a 125 horsepower increase in mass flow rate. You are going from the exact same boost response, the exact same linear response throughout the gears from a turbine perspective using a 10-blade, zero cutback wheel with a redesigned, smaller and lighter compressor wheel, which obviously will increase your linear response due to the fact that the wheel is smaller, the mass of the compressor wheel is smaller, and you are driving that wheel a lot more efficiently with the size of the turbine blade. Guys, to put this into perspective for you, back in the late 90s, early 2000s, we used to play around with Garrett turbos, and we used to use the TO4E Q-trim wheel, which used to measure, in actual fact, I have one right here, and this specific wheel on the inducer measured 75 millimeters, and the exducer measures 65 millimeters. Now, to put that into perspective, we used to use this with a 60-1 compressor wheel. 60-1 compressor wheel was considered a high-flow wheel. It measured 59 on the inducer and 76 on the exducer. We then went to something called a Volvo wheel, which we gave the nickname of in our country, and that was a 61 millimeter inducer and an 82 millimeter exducer. So something similar to your GT35 ball bearing size family. This rotating assembly was good for 600 horsepower. At a push, high boost where your thrust would fail on you, which was the biggest cause of failures of these turbochargers back in the day, would be above 1.8 bar, 2 bar boost, but you'd start seeing diminishing gains from there. So back in the day, 600, at the most 620 horsepower you'd get from a similar sized rotating assembly, which now, if you compare, the exducer is 67 mils versus 76 on the inducer. You're talking a couple of millimeters on the turbine side. On the compressor side, you're going from a 7-blade splitter design, 64.5 millimeter inducer, and an 87.5 millimeter exducer, down to a compressor wheel that measures 64 millimeters on the inducer and 84 millimeters on the exducer with one less blade. The wheel is lighter, the wheel is smaller, and the wheel has 125 horsepower more to offer. The increase in mass flow rate is absolutely phenomenal. The S300SX range is proven, lending its reliability from the industrial sector where these turbochargers are expected to work in extreme environments under high loads, high boost applications in exceptional operating conditions, and they do that with absolute reliability. It's not uncommon to see these turbos in an industrial application boosting 2 bar plus all day long, and these engines last for thousands of hours before a midlife rebuild. The bearing system in these turbochargers are proven. You can take this turbocharger to whatever boost pressure you want and forget about having any thrust issues. Unlike some of the other turbocharger brands where you start exceeding 1.6, 1.8 bar boost, and the first thing that happens is you have axial loads that exceed the thrust bearings capabilities, and you start getting end float, contact between compressor and turbine wheels and their mating housings, and you'll end up with a catastrophic failure. These turbochargers are journal bearing, they run 360-degree thrusts, they have got exceptionally strong and well-designed bearing systems. The thrust pads are more than big enough to sustain any axial load within, obviously, your compressor map and your boost limits, but it is an ultra-reliable bearing system that should never ever let you down. The turbochargers are oil-cooled, and you'll obviously see on the bearing system there are no water cooling jackets. Less hassle with regards to routing water lines, ease of installation, ultra reliability, whether it's a 300 horsepower setup all the way up to 1100 horsepower. All right, guys, that's it for the SXR review. Hope you guys enjoyed that. Let us know in the comment section down below. We've got all these turbos in stock ready to ship. Give us a shout if you need any assistance in turbo matching. If you have a project you're building and you'd like some more information about the SXR, which is the best option for you with which housing, we're happy to help you guys. And remember, like, subscribe. Catch you next time.